All right, thank you. How's everybody doing? Okay, so I am Tim Freitas. I am the product manager for Atlas Search. Previously, you may know some of my work from companies like DigitalOcean and Giphy, where I led the search team there, growing from a small handful of requests to billions and billions of requests a day. So most of what I know about search, I learned the hard way scaling, and hopefully we'll apply some of those lessons at MongoDB as we grow. Also, if you're annoyed at GIFs being in the world, I'm really sorry about that for two reasons. One, it's mostly my fault. And the second is that you're going to see some GIFs in this presentation, just as a warning. All right, so why full text search? Why did we do this? The way I like to think about this and talk about this is that, and Elliot mentioned something about search being essential to every application. I would go a little bit farther than that. I would say that most applications are actually search applications. When people talk about a Facebook's newsfeed algorithm or something, well, newsfeed is actually just a search. It's a very complicated search. There's lots of facets to that search. Who you're friends with, who you've interacted with last, what advertisements you're going to get seen, et cetera. But at the end of the day, that's an ordered search and an ordered list of things that you're, where queries being run, these things are being put together for you. Take Netflix as a pre-composed search of things you might like. Reddit is a search driven by the subreddits you've subscribed to and what's popular right now as far as upvotes and downvotes and those sorts of things. So search is everywhere, and MongoDB search up to now has been a little bit difficult. The other thing to talk about when we talk about search is that search is actually really hard, and that's because it has to do with relevance. So let's say, if you're a developer who's worked in the search area, you've been a search engineer, all of this will sound really familiar to you. So, if you are all working together on a site, the developer might think that the best search possible is the one that just simply matches the most terms, right? But marketing might say, hey, why isn't the promo that we're running at the top of search results? Everybody should be seeing that. The product manager, might be, if I type in an exact product name, just skip the search altogether, just take me straight to the thing. I know exactly what I want. It's a very specific search, right? The UX team might be, well, users need categories instead to be able to find this stuff. Just a search bar, no one's able to really find anything, they need some help. They're looking for a person on Pinterest or something and not like a particular recipe. The CEO, as they sometimes do, just be like, I want this result right now. Please make this result at the very top of the search now and for forever. And your customers, if you're German, this just means I can't really find this thing. Actually, well, it's more like an American can't find something in German. Germans are very good at English. But in any case, often internationalization is another thing that comes into play in the search. And so these are some of the problems that you'll find. And the takeaway is that search is about relevance, not the one true correct result for a search. So this is what the experience is like today, searching with $ text in MQL, in Mongo Query Language. So if you were to perform this search here, and in this search, we're looking for the movie Chicago, and it's got a spelling error in it. Well, you don't get anything back. You don't get any clues or anything. You just get an empty set. There's nothing there. So spell correction, or fuzzy matching, as an example, is it's really actually pretty difficult with the existing operators that were there before and are there today. And it's only really reasonable to solve for typos in this above case with something like a regular expression, but that's incredibly computationally intensive if you're searching across every term. If you know where in the string the error is going to occur and you're willing to wait a long time, you might be able to get by with this. I've even seen some users do something crazy, like take all the possible misspellings of words and put them inside of their own collection and search against that, and then sort of redirect that search back to the correct spelling of something. And this is all insane. And getting your indexes is hard as well here. It usually involves a compound index, which can lead to slower query times depending on what's being searched for and if you do it wrong. So in Atlas search, things are a little teeny bit different. They're a little bit more verbose. I'll take you through this. So here's a similar query using full text search. Yeah, there's more code here, but let's go over what's new. So you see the searchBeta operator first. So searchBeta is part of the aggregation pipeline alongside all the other aggregation pipeline tools. And the great thing is that you can actually chain it with all the others, so you can perform some pretty complex searches. Here I'm just doing a limit of 1 at the end, but you could do a lot of things. You could pipe it through match, facet, bucket, so you can do like faceting, grouping, all of the sorts of things that will sort of help you build robust search experiences on top of this. Typos in this case are handled at the next thing there, which is the fuzzy operator here. And max edits 1 here means that it's willing to accept 1 typo, and that's like a transliteration where 2 characters are switched, or a misspelling where 1 letter is different, or if 1 letter is just completely missing. There's the highlight path here, and what that does, if you look on the right, is returns this highlights object that has a whole bunch of data in it. In this case, it is searching the full plot field. If you remember the demo from earlier that Karen gave, this is how she did her highlighting. And it is going through that, and it's picking out everything that actually matched the search term, or the corrected search term in this case, as a hit. So you can use this to go on ahead and do things like make results bold, for example, for words that match your search. And then finally, there's a score right there at the top on the right. So the scoring comes by default in Lucene, which is backing full text search, and we'll talk a little bit more about that later. But every query has a score that is relative to how likely it is to be the most relevant result. And that's a big difference. But in this case, this works, where the $text operator query would not. So let's talk a little bit about like query time scoring here. And so if you were to do something in text, all the sorting that you have to do afterwards to determine relevance is left up to you. You're sorting everything in whatever order you think is most accurate, which can be difficult. In Lucene and in searchBeta, all of the scoring actually happens during the filter stage. So you can actually influence the scoring inside of your query instead of waiting for these results to come back to you. This is a really important distinction, which I think you'll see is a little bit more important later as we go on. So it's time for a demo. We're going to search for movies. I'm actually not going to do that because Karen went on ahead and did that earlier, and she does a good job and has a great demo. So I'm not going to subject you to a slightly different movie demo about searching and scoring. You've seen it already. Instead, we can just slide into talking about the architecture and talk a little bit about how how full text search works, and how we put it together. So first, we built this on Lucene. As Elliot mentioned, there is not a lot else out there that really just kind of works. Lucene turned 20 this last year, so it is a 20-year-old open source project, and it's kind of hard to compete with that gravity when it comes to things like supporting languages, and as I mentioned before, there's a bunch of pre-existing functionality that I just talked about that you get for free. So highlights, fuzzy matching / spell correction, query time scoring. Lucene also has this concept of analyzers, which are a way to filter your text and either index it differently or query it differently. The most important aspect of analyzers is probably language support. So there's support for all the major Western languages, but there's growing support for Eastern languages too. CJK there stands for Chinese, Japanese, Korean, and there's bigram, unigram support for those languages as well as Western Romantic languages. And Lucene has an inverted index structure, which we'll talk about here in a second. It's a little bit different from your standard index, and what this means is that you get really fast searches compared to iterating through your entire database looking for a particular result, or your entire index. Okay, so here's a real-world example of an inverted index. This is a little dorky, but hey, I think I'm in the right place. So as a reformed literature major and being forced to study Shakespeare in college, I'm familiar with this thing called concordances. And what a concordance is exactly an inverted index. It's a sort of reverse lookup. So what you do, or what a concordance does, is it takes every work by an author and it looks for every word that existed in author's collected works, and then it directs you to where you can find those things inside of an author's work. In this case, Shakespeare. Shakespeare's a popular one. So I'll sort of play this through, and here's search for Hamlet. Hamlet happens 104 times or something in 98 different speeches, and here's like a direct link to each one of them. So Act 1, Scene 2, speech 201, right there, there's Hamlet. And hey, this is a full text search that's being used on this. There's highlighting. There's a lot of the features that you saw earlier in Karen's demo are possible today with the full text search beta. And the thing to realize about this is that it's really, really fast. So we didn't search the entire play Hamlet to do this. What happened is someone went and indexed all the places where Hamlet existed. Only those things existed in the index, and that's what you looked up, and it's just a pointer to where that existed. So if you think about it, this is a lot faster. There's whatever it was, 102 lines that mentioned Hamlet. Well, there's more than 4,000 lines in the play. So we've immediately narrowed our search from looking through the entire 4,000 lines of the play, however many words that actually ends up being, for the term Hamlet, to just about 2% of the available lines in the play. That's way faster. So that's how modern search works on Lucene. Other tools based on Lucene, they're all sort of initially based on that concept of an inverted index. But let's talk a little bit about analyzers and sort of show how this works. So let's say I am trying to index planes, trains, and automobiles. John Hughes movie from the 80s, for those who are familiar. I resisted my urge to put a bunch of GIFs on the slide. So there are different analyzers in Lucene, and it's not super important to know the differences between them. You don't need to know this in order to use full text search. But I'll walk through how they behave differently. So Lucene keyword simply takes the entire thing that you feed it and treats it as a term, one word. That's what it does. So in this case, it would put planes, trains, and automobiles in your index as just that term. And let's just say in this case, it's in your document is ID 3, right? So it knows that planes, trains, and automobiles is indexed to the ID of the document that holds it, in this case 3, and that's all that it holds in its index. It's just this pointer to the ID where that term exists. And if someone were to search for the exact string, planes, trains, and automobiles, then they would find it. The Lucene.simple, what it does is it just breaks everything down, lowercases it, and removes white space. So in this case, you get planes, trains, automobiles. It ditches the ampersand for reasons I won't get into here. But it's making that term more composable. So if someone searches for automobiles, they're still going to get this result if they're looking for movies that would be titled automobiles. But Lucene also has the concept of language awareness. So Lucene.English does the things I talked about with Lucene.simple, but it also understands the concept of pluralization and stemming. So if someone searched for plane or train or automobile or plane, train, and automobile, that search would be a success because the English analyzer understands things like pluralization, gerunds for verbs, that sort of thing. All right. And you can use these analyzers at query time. You can index things with several different analyzers types, say like both English and French, and then choose at query time which language you'd like to apply. This is sort of like what the output of these look like. So in this first one, if you search for planes and there's a regex there, regex is true, or you're trying to find planes, trains, and automobiles that way, then in that case, what happens is that search regex planes is what gets passed down to Lucene in a sort of run. Lucene.simple, in this case, there's a typo in there, but we have our fuzzy operator working, and it sort of passes it down. And that code down there is kind of what gets passed to Lucene, and Lucene sort of realizes, hey, this is really planes, spits that back out upstream, and fixes it for you, and talks back to your Mongo shell with the correct result of which ID is associated. And then finally, in the last example here, if you're searching for two terms in a query, a Boolean OR is performed. So it's searching for plane or train, where the highest score is something that matches both, but it's possible that you get results for plane or results for train. There's lots of ways to change this behavior that I won't go into depth here, but this is just generally how things work by default. So how did we accomplish all this at the software layer? So when building full-text search, we had to introduce a new service to make sure that this would work. And the reason why is because, well, we have a whole new database that's storing data, living alongside the MongoDB that you know and love. So each of these needed to be modified in some way in order to solve the problem of speaking to a different index, an inverted index. The first two you're probably familiar with, MongoD and MongoS. If you're not, MongoD sort of handles your databases and collections, and MongoS handles sharding if you have a sharded cluster. For MongoD, we had to add the searchBeta aggregation pipeline so that people were able to use this in the shell and drivers and any APIs that would leverage them. And MongoD talks wire protocol to MongoT. So just as MongoDs talk to each other in a wire protocol, the same is true of MongoT, which is the new service, which I'll talk about here at the end. For sharding, MongoS, well, we needed to have a shard-aware implementation. And specifically, we had to implement scatter-gather queries that worked for search relevance, which is a bit tricky. So the way that search works is it looks for everything inside a corpus of documents, and out of that, it picks a thing that's the most relevant. And it picks that based on, and I'm oversimplifying, but just relative rarity. In the case of Hamlet, if I were to search for Hamlet in the Shakespeare concordance that you saw earlier, well, it only exists in one play. But to know that, it has to search across all of Shakespeare's plays to know, hey, the 108 times, 102 times Hamlet occurred were just all in this one play. If each play were a shard, you can imagine that that's where this gets a little trickier, in that you want like the best result across all data. So we had to implement a scatter-gather-aware version of search that looked across all clusters and shards, reported back up through the shard, and performed relevance there. And then there's MongoDB, which is a service we built that on the back end is powering full-text search. As I've mentioned a couple times, it's based on Apache Lucene, specifically Lucene 8. It's integrated into MongoDB Atlas. It is a separate Java process from MongoDB. It's running completely separately by itself, but it is co-located with MongoDB for reasons that will become important and obvious in a couple of slides. So let's talk a little bit about like how this all works. If you are trying to perform an initial sync, you want to set up an index. How does search know what data to get? And what does the sync process actually look like? So first, if you try and just run a full-text search query today, if you just go and put searchBeta in your aggregation pipeline and try and run a search, it will return nothing. And the reason why that is it's not total magic. We don't just proactively index everything that's inside of your database and collections today for a lot of reasons. One, I think you would be less than happy at the amount of data that you're suddenly using as we shove everything into another database and index. But also, you may want to only index selective fields, right? You don't want to expose your entire database out to a search application in the world in most cases. You want to be targeted with which fields in your collections are actually the ones that are important to you. Although by default, if you just press the magic green button when you go through and create an index, it will do exactly that. It will take everything in a collection and make it searchable. You're able to configure that. So it won't work right away, but if you go on ahead and create an index definition, which you're led through in the creation process, that kicks off a request to the automation agent, which deploys MongoDB on the same node where your MongoDBs are living for each node. 3 if you have a replica set, a lot more if you have a bigger replica set or many shards. A collection scan is performed. So it looks at every field that you defined, and in doing so, it finds things that match that are text fields, or whichever fields you've defined in your index definition. It looks for those in your collection, finds them all, does everything that I talked about on the last slide, where it goes, hey, this, the word data is in documents or 4, 5, 7, and 9, and so when someone searches for data, it just looks through those documents and only those documents. And MongoDB and MongoDB are now in sync. In a steady state where the initial indexing has already occurred and you're no longer iterating through your entire database anymore, what happens is a document gets added to your Atlas cluster. This starts on the primary MongoDB. Every time a document's written, there's a change stream that gets updated inside of Atlas. And we, at MongoDB land, are just monitoring that change stream in real time. So we're constantly looking for any sort of changes at all. If a new field has been added that contains data that you wanted indexed, if, as Karen alluded to, this is dynamic. So as more data comes in, and in the case of movies, you add more movies documents and they have a full plot field. That full plot is going to get populated into your search index and become instantly in quotes, trademark, available for people to search in your index. It's pretty fast. So this is what that whole query lifecycle looks like. So in this case, if you were searching for a movie with the name Star Wars, what will happen is that wire protocol communication will happen and go into Atlas. There, that aggregate call is broken down and passed over wire protocol to the MongoT, which lives on the same host. So this is a local host communication right now. And it breaks it down the portion that it cares about, which is the search query portion. It turns that into this Lucene query. Lucene's in Java, so this Lucene Boolean query that said it should contain the term star or wars. It finds, these documents, star is in 123, 124, wars is in 123 and 125. So the document that has 123 is probably the #1 document, since that term exists the most everywhere. And then that gets passed back to MongoD, who brings it back to you inside of your application. So all of this happens without you really being aware that we're talking to a separate service at all. And then there's sharding. So sharding works largely the same, in that each cluster is sort of determining independently what most relevance are there, and then scatter-gather querying that back up. So a request is made to MongoS, which on a per shard basis is doing everything that we talked about in the slides before, passing it down to a primary in each shard, where it's running that query and then passing it back up to MongoS, and then that result makes it back out to you. So it's not that much different, except for some magic at the MongoS layer, where we're sort of aggregating results for you. All right, so what's next? What is on the feature roadmap? There's expanded data type support. So our #1 priority right now is just making sure that search works with all the different types of data that are out there. Today, it supports merely text. Very soon, that will not be true, and we will support most of the data types that MongoDB supports natively. So, think integers, geography, dates, all of those sorts of things will become relevance-based searchable. Synonyms are coming. There's a common thing where if you're searching for one thing, you're really hoping that users end up somewhere else to share some, Giphy battle stories. If someone was searching for Yeezus, they really meant Kanye West. People search for Riri. We know who Riri is. Riri is the Queen Rihanna. That's where we want the search to go. So that's something that's coming up. Improved operators and syntax. So the beta that's out there, we have a limited set of operators with syntax that's likely to change a little bit. We have some improvements that we want to make to just make querying easier and less verbose. And then finally, the thing that we know we're going to do is some architecture and performance improvements in order to really make this scale. We're continually improving how we approach the deployment and general performance of search. And that's because search has radically different characteristics depending on your particular environment. So we're working on making sure that we have the most flexible, highly scalable environment for every possible search deployment that we might encounter over the years to come. And then finally, we have a few things in mind outside of that, but we'd love to hear from you. So we're very early in this product, and that gives us the luxury of being able to take feedback from folks in this room and try to build exactly that, which is a rare and treasured luxury. So please do find me, give me feedback. You can give me feedback in the Q&A if you like. But I'll be around all afternoon over at the Ask Experts booth over there if you would like to chat. But we are building fast, and we'd love to hear from you about what you're using search for, the problems you're having, the joys you're having, mostly the problems you're having, and be sure to incorporate those inside of our future feature development. And with that, I think we'll open it up to questions. I left a little extra time here at the end. So if anybody has any questions, just raise your hand and someone will be rolling by with a microphone.
I'll take the one in the front first of all.
Thank you. It was a very nice presentation.
Thank you.
I'd like to ask you, now when we need to do a full text search, we need to have Java installed on the computer? Because previously I had just to download MongoDB package, put it in a folder, and launch the daemon or launch the MongoS. Now for MongoT I need Java.
So no, but that is because today full text search is an Atlas-only feature. So this is a hosted search feature. This only works on your existing Atlas collections as we stand right now. So today the answer is no, you don't have to download Java just because you won't find full text search in the on-prem version of 4.2. That may change at some point, but today that's the reality.
Okay, thank you.
So the question back first.
In Elasticsearch, it's possible to customize the way the text is indexed, in inverted index, to have a real customization of the full text. For example, decide if you want tokenization, lemmatization, but also if you want n-grams on words or letters, and will it be part of the roadmap for 2020?
Yeah, you were talking about lemmatization, is that what you were talking about there? Yeah, so we are going to expose some dials out to end users in terms of tokenization and stemming options and those sorts of things. You will also be able, it's on the roadmap right now to add custom analyzers to do that sort of thing. We're probably a little bit ways out from exposing that, but it's something that we are seriously considering and is likely to make it out into the public. Yeah.
Okay, thanks.
Yeah.
So you mentioned at the end of the talk that you plan to add support for more data types.
Mm-hmm.
I was wondering if you could expand on that. So will you only be able to filter, or will you be able to do a rank feature? So in Elasticsearch you can map a field so that you can compose the final score based on the rank for multiple fields. Is that on the roadmap?
The second one, yes, that's on the roadmap. Yeah. That probably won't be part of the initial launch of data type support, but it will come soon thereafter. That's part of why we're doing it.
Thank you.
Any other questions? Simon, there's one over there.
So what is the impact on performance on the machine, the Mongo instance?
Yeah.
We've now got two pretty heavyweight systems running.
Yeah, it's a good question. That's, I think at some point I said this is the way the architecture works today, and mentioned something about changing or scaling that and constantly improving that. Part of that is sort of understanding at what point it makes sense to run in a shared environment and in what sense it makes not to. And some of that depends on the overall machine type and how many resources you have. Generally I can tell you that building an index is extremely CPU and IOPS intensive depending on what you are actually building, and during those times there are spikes in performance that are strong enough that they could potentially impact your main MongoDB database and collections. And that's one of the things that I'm talking about when I talk about improving architecture and performance. I would say that it's likely that eventually these won't be co-located anymore. It's pretty trivial for us to do so. It's talking wire protocol just like everything else. We can put these on separate hosts. Today we are not doing that for latency reasons and also to save consumers cost. We don't want anyone to have to spin up an entire another cluster today just to be able to perform search and try it out while we're in a beta state. In beta, we're just trying to get people to be able to use it as easily as possible without waiting on us to come up with the one true architecture that's going to scale for everyone. However, as we approach GA, I think you can expect that that probably will no longer be true, and this talk will be irrelevant and can be ignored.
Thank you.
Another question then.
The question maybe is not related to just to this presentation. Why Lucene and not something like Sphinx or, I don't know?
Yeah, it was really a matter of, and I think, I hinted at this, it's just that Lucene has like very strong gravity. It's 20 years old. It's super rare for an open source project to be 20 years old. And if you make it that far, there's probably a really good reason. And Lucene just really had like the most maturity around being able to support really different types of searches that were important to relevance. And language support was a really big deal to us. International language support, especially as our global footprint grows, was a really strong consideration. And we just didn't find anything else that we felt had a good feature set, ongoing development, and a community we could give back to as well if we made changes. Just frankly, like mind share and global support. So we don't see Lucene going anywhere, and in fact, we expect to help keep it around for a long time to come.
Okay, thank you.
Any other questions?
Hi. So, quick question about the settings for which fields to include or exclude. So
Yeah.
presumably you can change those after you've set up text indexing, and that would kick off some sort of re-index process.
Correct.
How is that managed operationally, and is there any impact to the to clients?
Operationally, it's treated just as like a re-index event, all of the same impact that would happen during a re-indexing event will happen again. Presumably, if you're narrowing the scope of fields that you're indexing, it will happen for a shorter period of time. But today, the way that works is it will kick that off. So, some architecture changes we can make. In the short term, short of moving things off onto another host, is, for example, to build the index on a secondary and then promote that back up to the primary. There's things that we can do there that we haven't turned the dials on yet because we're pretty early. And we're a little bit more focused on just getting more features out there over trying to optimize for performance. We'd love to have as many people use it and give us feature feedback and sort of build that. We know that we can solve the performance gap. And if it becomes a big enough issue in beta to where it's the thing that would keep someone from promoting it once we go GA, we'd love to talk to those people and learn exactly what they're doing. But most of it does revolve around those re-indexing events, as you've inferred.
Any other questions?
Hi. So you said this feature is only available on the Atlas cluster. I was wondering if it's available on the Visual Cosmos API. So you can spin up Visual Cosmos MongoDB. I was wondering if it's available on that, or is it only in Atlas?
I'm actually not familiar with, do you mean like the Cosmos DB plugin for VS Code, or is there actually, I'm not familiar with Visual Cosmos, I'm afraid.
in Azure, you can spin up Mongo through Cosmos. So that has an API.
You know, it is part of all the core APIs. So as long as Visual Cosmos is leveraging a MongoDB API or MongoDB API, in theory it should work just fine.
Tim, can I just interrupt a second?
Yeah.
Put a bit of colour. So Cosmos is an emulation of the MongoDB API. So it's a separate piece altogether. They emulate the API along with a bunch of other things, but the underlying architecture is totally different. And so what we're talking about here is essentially instrumenting Atlas clusters with Lucene to deliver full text search. So you're not going to find this part of any form of other database technology that emulates the MongoDB API. This is native to MongoDB Atlas clusters. Okay? Cool.
Yeah. If you were using a Cosmos IDE, it might work. But if you're talking about does it work inside of like Azure or something, the answer is no.
Does that answer your question? Awesome, cool. Any other questions? We got a
one at the back, Tim.
Oh, one at the back, excellent.
Hi there.
Hi.
How's this going to work with, or does it work with field level encryption?
That's a great question. I don't know the answer to that yet. It probably will not by default because the entire point of field level encryption is that you can't actually see what's in there. So you know, you don't really want someone being able to search for your social security number, right? So, but internally, you very well may, right? So we don't yet have the concept of like passing in an encryption key or anything like that. The way that it would work now is if you indexed a field that had field level encryption in it, that would be garbage and then would have to be decoded by whoever held the key for for that field. So it's technically possible. I don't know when we may get to that. Right now we're focused on some broader use cases. You're not the first person to ask that question, so it's a smart question. For the foreseeable future, though, it's probably not going to be a key focus for us. We just want search to work on all the other stuff that isn't encrypted first.
Okay, thanks.
Mm-hmm.
Right, we've got time. I think we can squeeze one more in. Simon, can you run there for me? Thank you very much.
So you said about being able to run searches on sharded collections. Any plans to leverage similar technology to enable multi-table or multi-database indexes?
Yeah, that's a really good question as well. My short answer is yes. The longer answer is it's going to be a little while, but yes. It's a common use case and it's a problem. So, if you use one of the existing search services out there, the way that they work is to shove everything into a monolith. So if you're using Atlas today and you want to use one of these third-party hosted search offerings, you need to pick up all your data, send it outside of Atlas and to somewhere else. I won't say any of their names. You know who they are, and then from there, now you have a monolithic database over there that's a copy of all the data that you had, but some of it might come from different databases and collections and those sorts of things, which makes the problem even harder, right? Now you have to migrate certain portions of different databases all the way over there. That's definitely a problem that we want to solve. I would be surprised if that's something that isn't there in the next year, let's call it something like that, to be fair. Don't have a clear timeline yet. It kind of depends on how all of our primitive building feature work goes and getting all of the data types right and getting relevance right and getting performance right. But that's one of the specific problems that I would like to solve as someone who formerly had to deal with that, as being like, well, I have four databases of truth here, right? It's like I have my user database, which is over here, which is separate from my session database, which is over here. I really want to search across both those things. How do I do that? Well, I have to migrate each of them. into one specific collection. So that's something that we'd like to save users the work of doing. But it's not on the Q4 roadmap.
Okay, that's going to wrap up the questions now. Tim, where are you going to be later on today?
I am going to be at the Ask the Experts booth over there, which is straight across the way. You can find me there. I do have some actual scheduled appointments, so I apologize if in advance if I have to like stop and go take those. Or you can sign up for an Ask the Expert slot, although I'm not sure how you do that. So I'll be right over there, although I may be all of a sudden looking like Kermit the Frog. They'll probably put me in one of those green shirts. So look for the guy with the glasses.